Good morning, class. We have a lesson for you today. The law of cosines. Similar to the law of sines, where you're given angles, you're given sides, and we're going to try to solve the triangle by solving it, meaning finding all three angles, finding all three sides. But the law of cosines has its parameters. You can only use it for certain triangles. And if you want to follow me, this is section 10-6 in your online book here, mathematics. 10-6, the law of cosines. So we're going to write down what the law of cosines looks like. These are formulas that you need to write down. I'm going to put them right up top here. Hopefully you can see this. A squared equals B squared plus C squared minus 2BC cosine A. And try to see if you can pick up a pattern here. A squared plus C squared minus 2AC cosine B. And finally, C squared equals A squared plus B squared minus 2AB cosine C. The pattern I want you to pay attention to is as follows. If you have an A squared here, then you have a cosine A at the end. If you have a B squared, you have a cosine B at the end. And if you have a C squared, you have a cosine C at the end. The other pattern you want to pick up is the two values in here, B squared and C squared. Notice that they are in the middle. A and C, they are in the middle, and A and B, they are in the middle. So this is the law of cosines that you're going to be using. No need to wonder how we derive the formula. We're just going to use it. And we're going to use it in two examples. And just remember that some of the tools that you guys are going to be using today are also the inverse functions, which you'll have to use shortly. So let's start with, this is example 1. Again, follow me. This is the first page of section 10-6, the law of cosines. So let's give you an example here to start off with. Okay. As we're drawing this example, I want you to keep in mind that this will only work for certain triangles. Specifically, triangles that are giving you the following parameters. This works when the triangle is given side, angle, side, and when the triangle is given side, side, side. If you're given those parameters, you have to use the law of cosines. Otherwise, if you're giving any of the other parameters like angle, angle, side, or angle, side, angle, or even side, side, angle, you would have to use the law of sines. But given these parameters, side, angle, side, 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 you would have to use the law of cosines. And here's my example. Okay, 5, 7, and 100 degrees. Notice this is a side, angle, side. Side, angle, side. So we have to use the law of cosines. Well, why don't we just substitute? Take these values and substitute them in. One of the things I like to do is always identify who we're given, because when we solve the triangle, we're going to have to solve all the parameters, the angles, the sides. So that's what we mean by solving all the parameters. Well, let's see what we have. We have angle B is 100 degrees. We have, what is this? Little c, which is 5. And we have little a, which is 7. Absent from this is the measure of angle A, the measure of angle C, and also absent is little b. Well, which one of these should we use? Well, you could use any of those that are given up there, but because we're given the A and C, I might as well use this one here and see if I can solve for B squared and then start to trickle down. So let's try to solve for B squared here. All right, B squared, well, it's still unknown. So we'll leave that as unknown, B squared, okay? Do I know what A squared is? Certainly, A squared is 7, that's a 49. Do I know what C squared is? Certainly, that's 25. Minus, now here we have 2 times A times C. Well, what's A times C? 7 times 5. That's 35. right? So I might as well write 2 times 35. And then of course, cosine B, which is given, I'll just substitute that with cosine 100. All right, the rest is pretty much simplifying, multiplying, and trying to achieve values on one side so we can solve for b squared. So why don't we do that here? Why don't we take care of this and start to simplify this equation here. 49 plus 25, what does that give you? 74. Minus 2 times 35, well, that's a 70. Okay. What about cosine 100? Now, cosine 100, when your calculator is in degree mode, it's going to give you the following value for cosine 100. It's going to give you a negative 0.1736. Now, that's not wrong. Remember, earlier I said we're going to be using inverses. So let's try to get all this stuff on one side of the equation and see if we can kind of like trickle down. And my bad, this is 74. All right, so let's do this. See if we can kind of take care of some of these. Why don't we multiply here and then subtract 24? Okay. Now, if you multiply here, you're going to end up with the following. You're going to end up with, let's take care. If you do all of this, negative 70 times a negative number, which is going to give you a positive number, and then 74 plus whatever you get here, you're going to end up with b squared equals 86. How did I get that? A negative times a negative gives you a positive. So you're going to end up with a positive number here, plus 74 will give you 86. If we take the square of both sides, if you take the radical of both sides, because this is how you solve, then you end up with the following value. You end up with 9.3. Okay? We know the value of b, little b, and we can populate that here. We know that this is 9.3, this is 9.3. Well, we still have 2 more angles to solve. So we're not done yet. But we can certainly use this now. It seems to me that we're given side angle. And if you're given side angle, which means now we can go back to the law of sines and use the law of sines. So why don't we do that? Why don't we use the law of sines to solve the rest of the angles for this one? You might say, well, why can't we use the law of cosines anymore? The law of cosines states that you can only use it if you're given side. And now we could use the law of cosines because now we have side. But to me, law of sines is still fresh in my memory, so I will use it. Let's take this information here. Make sure you copy it or pause so we can continue here. I will erase. Make sure you copy it. Hit the pause button if you have to.
Hello, Crespi family. If you have not yet completed the survey that was sent out earlier this morning regarding meals for tonight's dinner, please do so as soon as possible so that Lulu can have a head count and make sure that we have food for everyone. Okay? All right, thank you.
Just like you were in class with the interruptions, but now you're at your home. Let's see if we can use the law of sines to solve the rest of the angle. We still have to solve for A, and we still have to solve for angle C. Well, we do know what sine B is, right? We can substitute this with sine 100 degrees. And we do know what little b is. After all, we just got it, 9.3. Now, take your pick. Do you want to solve for angle A or angle C? It doesn't matter. We're going to end up solving for both of them. So let's just pick A. Why don't let's start with sine A. So I can leave this as sine A, which is a mystery, but little a is not a little mystery. Little a is 7, okay? Well, let's cross multiply here. Why don't we take the following here? We'll take the sine of 100 times 7 equals the sine of A times 9.3. So why don't we try that? This is going to look like the following here. It's going to look like this. We're going to say sine 100 degrees times 7 is equal to sine A times 9.3. Okay? We're using the law of sines here to achieve our goal, solving for the rest of the angles here. Well, why don't we isolate for A? Basketball players, isolate for A. Divide by 9.3, divide by 9.3. Now you got quite a bit of things to do here. I know it might be difficult to see, but I have sine 100 times 7 divided by 9.3. If you take care of all of that, okay, let's see if we can move over here. You're going to end up with, so sine 100 times 7 divided by 9.3 will give you approximately 0.7412. And all of that, 9.3 has been canceled on the other side. All of this is equal to sine A. Okay. Inverse functions, remember that. We have to use inverse functions to find what the degree for angle A is. And if you use your inverse function in your calculator, you get 47.8 degrees is equal to the measure of angle A. Inverse functions is that necessary tool that you need to carry in your pocket. Do we know what measure of angle is? Now we do. It's 47.8. And we could even populate our graph here with the degrees. Well, you might be asking, well, how do we solve for angle C? Well, the left would be to use the summation that all three angles equals 180 degrees. So you can take 180 degrees, subtract 100, subtract 47.8. And if you do the subtraction, you find out that the measure of angle C is 32.2 degrees. Okay? And you can show that over here. You can show that 100 degrees plus 47.8 plus 32.2 equals 180 degrees. Certainly we have the measure of angle B. Can you see that? We have the measure of angle A, and we can subtract to find the measure of angle C, 32.2. Would you like to try another example by yourself or together? Well, why don't we hit the pause button so we can do another example together. You want to guess what kind of example we're going to be using? Well, we use side angle side. In the next video, we're going to do one where we're given side, 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 and we have to use the law of cosines to find out. So stay tuned.